Hello everyone. Welcome to the next lecture on the module Earthquake Resistant Design of Structures. In the previous lecture we have seen one problem on this module. In this lecture we are going to see another type of the numerical. So first let us go through the question. A multi-story building has the following data. The plan dimension is 20 by 15 meters. Number of bays in x direction is 4 at 5 meters spacing. Number of bays in y direction is 3 at 5 meter spacing. Floor to floor height is 3.2 meters. Number of stories is 4 and the total height is 12.8 meters. The size of the column and the beam is 300 by 600 mm. The thickness of the slab is 150 mm. Live load is 3 kN per meter square. It is an RCC frame with brick infill masonry. Seismic zone is 4 and the strata is hard and with 5% damping. Estimate the seismic forces at each floor level. So this is the question and we have to find out the seismic forces at each floor level. So in the previous question also we have seen how to find out the seismic forces at each floor level. So this question is different from the first question which we have done. First of all, this is an unsymmetrical plan. And second thing which we have been also given the some extra information, that is damping is given to us and also the size of the beam and column is given to us. So let us see how to proceed in this type of problem. So I have just drawn the plan and the elevation. So in the x direction you can see the length is 20 meters and in the y direction it is 15 meters. So this is 20 by 15 meter is the plan dimension. And again your elevation, the height is 3.2 meters. So you can see I have mentioned the height and also the floors, first, second, third and the roof floor. So I hope the plan and elevation is clear to you. So now let us see what is the given data. I have also mentioned the given data so that it is easy for us to understand. Live load is 3, brick infill panel, it is already mentioned, so we know that which time period formula we have to use. Now slab thickness is given to us, seismic zone is given to us, size of the beam and column is also given to us, and it is hard strata with 5% damping. So let us start. We have to find out the seismic forces at each floor level. So again the first step, as we have done in the previous problem, we will first find out the seismic weight of the structure. So how to find out the seismic weight in this case? So let us see. First we will find out the dead load on the roof. Okay, so dead load on the roof is given by the self weight of the slab, the self weight of the beam and the self weight of the column. So remember this thing, whenever the sizes of the beam and column are given to you, so you have to find out the load in this way. So let us first find out the self weight of the slab. So how to find out the self weight of the slab? You know, self weight of the slab is given by thickness into density, and here we have to find out the self weight for the entire floor. So remember this thing, so we are finding out for the entire floor. So thickness into density into the entire floor area, the plan area of the slab. So thickness is given to us, this is 150 mm, so 0.15, let us consider density as 25 kilonewton per meter cube, and the plan area is 20 by 15. So this will give us the total self weight of the slab on the entire plan. So we got the self weight of the slab. Now similarly we'll find out the self weight of the beam. Self weight of the beam is found out by multiplying area, the cross sectional area of the beam, into density into the number of beams. Okay, so the cross sectional dimension is 300 by 600, so 0.3 into 0.6 into density is 25, and the number of beams we have to find out the number of beams. So here you can see, let us first how to find out the beams. I'll just give you some information. So first let us find the beams in the x direction. So always use this method so that you won't make any mistakes. So this is x direction, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So I hope you can see my pointers. So what I've done, I've just counted the number of beams in x direction. So similarly find out the number of beams in y direction like this: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So 15 in y direction and 16 in x direction. So total it will become 31 beams. And how many floors we have? Total ground, 1 2 3 and roof. So total it will be 5 floors. So that is the reason on one floor there are 31 beams. So in 5 floors it will be 31 into 5. So one floor is equal to 31 beams. I've also mentioned here. So I hope you understood how we got the total number of beams. So this is how you will count the number of beams. So we got the self weight of the beam as 697.5 kilonewton. Now similarly we'll find out the self weight of the column. So how to find out the self weight of the column? This is area into height into density into number of columns. So what is the cross-sectional area of the column? Again, it is 0.3 into 0.6. And what is the floor to floor height is 3.2 meters and density is 25, and number of columns, again you have to find out columns at the junction of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So all these are columns. So we got the total number of columns as 20. So we got the self weight of the column. So you can consider column at the junction at all the corners. So in that way you will find out the total number of columns. So we got the self weight of the slab also, the beam also, and the column also. Now the total dead load on the roof slab is given by, I have shown here the formula: self weight of the slab, self weight of the beam, and self weight of the column. So self weight of the beam is, slab is 1125, self weight of the beam is 697.5, and self weight of the column is 288 by 2. So why I have taken by 2? So on the roof slab, you know that the total height of the column is not the same as it is on the first or the second floor. So on the roof slab, the columns are extended only up to the height of the parapet wall. So the parapet wall, the height of the column is only up to the parapet wall height, which is normally taken as 1.2 to 1.6 meters. So that is the reason we have considered half of the floor to floor height as the height of the columns on the roof floor. So that is the reason I have divided this value by 2. Or you can do is, what you can do is, you can directly divide by 2 here, that is 3.2 divided by 2. So the value you get here you can consider in the dead load on the roof slab. So I hope this is clear why I have taken divide by 2. So the dead load on the roof slab is 1966.5 kilonewton. So similarly we have to find out the dead load on each floor, that is first floor, second floor, and third floor. So again this will be given by the equation self weight of the slab plus self weight of the beam plus self weight of the column. So self weight of the slab we have already found out, 1125, beam and column. So for the other floors it will remain the full value, that is 288 kilonewton. So we got the dead load on each floor as 2110.5 kilonewton. Now let us find out the live load on each floor. So live load on each floor, we have been directly given the intensity, that is 3 kilonewton per meter squared. So we can directly find out this with the help of plan area into the intensity. So again, as I've earlier mentioned, if the live load is equal to or less than 3, we have to take 25% of the live load, which is given in table 8 of IS code. So we got the live load on each floor as 225 kilonewton. So now we'll find out the total seismic weight on each floor, that is first, second, and third floor is dead load plus live load. So dead load is nothing but 2110.5 kilonewton and the live load is 225 kilonewton. So the total seismic weight on each floor is 2335.5. Similarly, the total seismic weight on the roof floor is dead load plus live load. So again I have mentioned that on the roof floor we do not consider the imposed load. So hence only dead load, that is 1966.5 kilonewton. So now the total seismic weight W is given by seismic weight of all the floors plus the roof floor. All the floors, that means first floor, second floor, third floor, and the roof floor. So hence I have done the addition of the first floor, second floor, third floor, and the roof floor. So this comes out to be 8973 kilonewton. So I hope you understood how we got this total seismic weight W. So this is the most important step in this type of problems. You should be able to find out the correct total seismic weight of the structure. So now let us go to the second step, that is the calculation of the time period. So the time period is given as 0.09 h upon under root d, because it is already mentioned in the question that it is with brick infill panel. So Now we know that this plan is not symmetrical in both the directions. So in x direction, the length is 20, in y direction it is 15. So we have to find out the time period in both the directions, in x and as well as y. So first let us find out the time period in x direction, which is given by 0.09 into h. H is the total height, that is nothing but 12.8, and d is the total x dimension, that is 20. So you can see in the plan the total x dimension is 5 plus 5 plus 5 plus 5, that is 20. So we got the time period as 0.257 seconds. Similarly, the time period in the y direction is 0.297. That means in y direction it is 15, 5 plus 5 plus 5. So now since the building is resting on hard strata, so again we will go to page 16 and see the value of SA by G ratio. So from page 16 we can see that for a building which is resting on hard strata, the value of SA by G is given as 2.5. So again this is for the values t less than 0.4 and greater than 0.1. So here we can see this value of t is less than 0.4 and it is greater than 0.1. So hence we got the value of SA by G as 2.5. I hope this is clear. Now let us go to the next step, that is to find out the design based shear, that is VB. So now VB is given by the equation AH into W, and in the question it is already given as the damping is 5%. So AH is given by Z by 2 into I by R into SA by G into 1. Okay, so this one is given when your damping percentage is given as 5%. So when damping is 5, your damping factor will be taken as 1. So this is again given on page number 17, table number 3. So here you can see the damping factors for the various percentage of damping is given. So for 5% of the damping factor is 1. So whenever the damping percentage is given, you have to multiply the AH, the coefficient, with the damping factor. So hence I have multiplied by this 1 here. I hope this is clear. So now let us find out the design parameters. First let us find out Z. So Z is equal to, it is given in the question that the zone is 4. So for zone 4, the value of Z is 0.24. So again you can find this in table 2, page number 16. And again I is equal to, so since it is not given, so we will assume it as a residential building. So since so in the question if it is not mentioned, so you can assume the building, if it is a normal residential building, the importance factor is 1. So this is given in table 6, page 18. So again the type of the structure is not given, so let us assume it as special moment resisting frame. So you can select on the basis it is given in table 7, page 23. So you can select either ordinary moment resisting frame or the special resisting frame. So based on that you will get the value of R. So let us assume it as special moment resisting frame, and the value of R for that is 5. So now we got the value of AH 0.06 and the design based shear as 538.38, where W is the total seismic weight, which we already found out. Now coming to the last step, that is distribution of the design lateral force. So the design lateral force at different floor is given by, we know this formula, Q is VB into Wi into Hi square upon summation of Wi into Hi square. So this is given in page 24, clause 7.7.1. So now let us see how to find out this. So in this problem, what we will do, we will make a table and we will do it in the tabular form. So again this is more convenient. So in the first problem I have shown you how to do it without making the table. So now in this I will show you how to do with the help of the table. So it depends on you. So whichever you feel convenient, you can follow that. So this is the story, the first column, 4 that is the roof, third, second one, and this is the weight of each story, that is Wi, and H is the height of each story from the base, and Wi into Hi square, the fourth column, and this is Wi into Hi square upon summation of Wi. So this is nothing but your summation, and finally we will get the value of Q. So this here in this case we have two time periods, that is qx and qy. So since this plan is unsymmetrical, so we will get the value of q in both the directions. Now since we have got the value as same in x and y, SA by G ratio is same, so we will get the same value for x and y. So now let us see how these values came. So for the roof floor, we know that the total seismic weight is 1966.5 and height is 12.8 from the base. So this table is nothing but Wi into Hi square, that is 1966.5 into 12.8 the whole square. So you will get this value, that is 322,191.36. So now here we have to find out the, so similarly you will find out for the third story, Wi into Hi square. For third story the height will be 9.6, that is from the base up to the third story. For second story W is again 2335.5 and the height is from the base, that is 6.4, and for the first floor it is height is 3.2 and the load is same, that is 2335.5. So for all these floors you will find out Wi into Hi square, and then at the end you will find out the summation of this. Summation of Wi into Hi square will give you this value, 657,008.64. So now you will go for the next column, that is the ratio of Wi into Hi square, that is 322,191.36 upon summation is 657,008.64. So then you will get this value, that is 0.490. So I hope you understood how you got this value. This is nothing but the ratio of this, you can see my pointer, 322,191.36 upon 657,008.64. Similarly you'll get the ratio for all the different stories. For story 3 it is 0.327, for story 2 it is 0.145, and for story 1 it is 0.0364. So now you'll finally we will get the value of q, that is the design lateral force. So at the roof it is 263.8, that means VB is nothing but, we have already found out, 538.38 multiplied by this value 0.498 is nothing but 263.8. Similarly in Y it is 263.8. So for third story again it is 176, for second 78.06, and for first floor it is 19.59. So this is how the table works, and you have to find out the value of each floor, the value of the force at each floor. And then finally you can draw the figure and show the forces on each floor in x and y direction both. So on the first floor it is 19.59, second floor it is 78.06, third floor it is 176.05, and finally on the roof floor it is 263.8. so this I have shown in both the directions, x and y direction. So this is how you're going to solve the problem in this type of the problem when the size of the beam and column is given to you. And one more thing, if the size if the wall thickness is also mentioned to you, then you have to find out the weight of the wall load also. I hope this problem is clear to you. So thank you.